Awesome. Let's see how we did. After you factored out the x and divided both sides by d minus a, you ended up with x equals ad all over d minus a. Just so you know, if we decided to do a different method when we were distributing, and if we brought the xd over instead, we would have ended up with x equals negative ad all over a minus d. So let's take a look. Why are we doing this solving in the abstract? Why are we doing this? Well, we're doing this so that when we do have very useful real-world equations and we want to solve for one of the unknowns, if I was given a formula for Celsius, for example, in number 10, but I really only want an equation for Fahrenheit, I can manipulate this equation. So I don't need an equation for Celsius and for Fahrenheit. If I have an equation for Celsius, I know the equation for conversion of Fahrenheit as well. So let's do that. Taking a look at number 10, it gives me an equation for Celsius. If you know Fahrenheit, you can convert it to Celsius. Well, I want to know, what if I only know Celsius and I need to convert it to Fahrenheit? That means I would need to solve this equation for F. So let's take a look. C equals 5/9 times the quantity of F minus 32. What am I solving for again? Oh, I'm solving for the variable F. I can't add 32 to both sides until those parentheses are gone. So the first thing I'm going to do to both sides is I'm going to multiply both sides by 9/5 to get rid of that 5/9. When I do that, I get 9c over 5 equals F minus 32. All I have to do now is undo subtracting 32 on both sides by adding 32. And I get my equation to convert into Fahrenheit is 9/5 C plus 32. You could also write it as Fahrenheit equals 9 times Celsius divided by 5, all plus 32. But what's important to recognize is that the 32, that constant term that we're adding, is not being divided by 5 as well. Now that we know that, how about you tell me, if I know the temperature outside is 30 degrees Celsius, what is the temperature in Fahrenheit? Do you think that's really hot or really cold? I'm going to give you 2 minutes to answer the question. Please pause the video and put the timer on for 2 minutes, and then we'll start back up. Awesome. Let's see, when we evaluated our equation, when C is 30, we end up that 30 degrees Celsius is equal to 86 degrees Fahrenheit. Wow, that's not very cold at all. Let's see how else we can use these literal equations to manipulate to get equations with what we want. So taking a look here, this equation gives the surface area of a cylinder. So if I had a cylinder, remember the two bases are both circles, and it's going to be the surface area. So if I dipped all of that in chocolate, everything that would be covered in chocolate, a shell if you will. So if we know the surface area of a cylinder already, but we don't know the height, what can we do? Well, let's manipulate this equation and just isolate h, solve for h. So let's rewrite the equation, capital S, and remember, capitals and lower cases represent different things in mathematics. In this specific equation, the capital S stands for the whole surface area. Little h stands for the height. Little r stands for the radius. If you change those to lowercase or uppercase and vice versa, you are changing what this equation is telling you. So please don't do that. Capital S equals 2 pi RH plus 2 pi r squared. Let's take a look. Did you get a little deja vu when you were writing this equation? Whenever that happens, I'm thinking about factoring. So if I want to isolate h, do you notice if I can factor out any terms? Taking a look here, I notice I have 2 pi r and a 2 pi r here, but that r is being squared. So a common factor between both of them are 2 pi and r. So let's factor out a 2 pi r. If I was going to multiply 2 pi r by something to get 2 pi r h, I would multiply 2 pi r by That's right, h. Plus, if I was going to multiply 2 pi r by something to get 2 pi r squared, what am I multiplying that by? That's right, I'm multiplying it by r. This exponent tells me how many times I'm multiplying. R times r is r squared. So taking a look here, remember we're solving for h. I'm going to undo the multiplying by 2 pi r by dividing both sides by 2 pi r. And then I'll have s over 2 pi r is equal to h plus r. Remember, we're solving for h, and now all we have to do is undo the addition. Subtract r on both sides, and we know that for a cylinder, the height is equal to the surface area divided by 2 pi times the radius, all minus the radius. Awesome. Now, can you use this equation to answer the question in part B? Notice I'm asking you to round your answer to the nearest tenth. Notice I'm asking you to round your answer to the nearest tenth, and I'd like you to use the pi button on your calculator to have the most accurate answer. Please use the pi button on your calculator, not 3.14 as an approximation. 2 minutes, please pause the video for 2 minutes, and I'll check back in with the answer. Let's see how we did. So when we substituted in 80 for s, 2 for the radius using our parentheses, and simplified, we ended up with 80 divided by 4 pi all minus 2. Notice we need to calculate this in our calculator first, 80 divided by 4 pi, and then subtract the 2. When you're putting this into your calculator, be careful because parentheses are really important. If you just put in 80 divided by 4 and then put in pi, it's going to divide 80 by 4 and then multiply by pi. To avoid that, please put parentheses in your calculator around the 4 pi to make sure it multiplies and divides 80 by the product of 4 pi. So taking a look, after we do that, we end up with about 6.36619, so on, so on. Hey, it's irrational number, never repeating, never ending. And then subtracting 2. So when we do that, we get approximately 4.4. Don't forget to go back to the problem to look at your units, and we get the height of the cylinder is about 4.4 centimeters. It's important to say about or approximately because remember we're rounding this value. Awesome job, guys. What I'd like you to do now is I'm going to give you the rest of the class period to work on your homework. You may be doing this on the Chromebook. You can also be working on a separate piece of paper. But because today's a shortened schedule and since I'm not here, I am giving you this gift of time. Please be respectful in working with each other and using this time wisely. I will see you when I return. Do your best and be nice to everyone. Thank you.